Yeah, I'm Shannon McCarthy. I'm from Datatex. We're a software company. Our primary product is an ERP for textile and apparel companies. We've been around since the 80s. We are installed in over 46 countries. We have offices in 9 countries. And thank you all for joining us today. Okay, so the textile and apparel industry is facing many challenges today. It's driven by technology change, the pressure inside the industry, as well as market dynamics. So on the one hand, we've lost somebody. Hope she's okay. On the one hand, we have a strong need for innovation. There's the ability to do new technology investments, whether it be data collection, automation, or artificial intelligence. Whereas on the other hand, there's intense competitive pressure in the industry that everybody's feeling. The market dynamics are requiring you to change your products in a fast manner. The order sizes are being reduced. The delivery times are being squeezed. And they're always asking for lower prices. So with these challenges, it makes it a very difficult time to invest in technology. So one area of opportunity to invest is to connect your management software to applications on the shop floor. And we've had some good success with a few of our customers making this connection. We're able to, from the management software, help drive what's happening on your shop floor. Both the schedule, communicating the sequence of events and what they should be doing with standard operating procedures, machine configuration, and so on. And then from the shop floor, we're able to get relevant information to our operations, information that we can use in our management software. So today I'm going to speak about a couple examples of those. The first case study is a customer of ours in Hong Kong that makes face masks. So as you can imagine, in the recent history, their demand for their products significantly increased. So as they had the need to increase their ability to produce the face masks, they also have a challenge with workforce. So they looked for automation. What could they do to automate some of these manufacturing processes and integrate it to their ERP system? So I'll show you a video of their prototype of the manufacturing that they chose to do.
It only requires 2 manual procedures.
So it's a fully automated factory. The operator brings the roll of fabric to the floor. It goes down a conveyor read by an RFID tag. A robot takes it off once it's read, puts it on a buggy. Second robot comes, retrieves the buggy, takes it to the inventory. Now we've scheduled manufacturing orders to a machine. We've allocated the raw material. So the robot then first sanitizes the buggy and then can take it to the machine where that production order is scheduled. There, the machine operator unloads the fabric onto the machine. The machine starts automatically, begins making the face masks. The automated packing at the end puts them in a box, labels the box. It's read by the RFID antenna, then gets brought to the finished goods warehouse, where it ultimately can be shipped to a customer. So we only have 2 human interactions with the product in the whole process, compared to their other lines where every step is a person touching the goods. So this was a prototype, of course. So where this actually is the machines are running. The RFID antennas and tags are all in place. The ERP is communicating with these devices. The scheduling is in beta, and the robots are still in the process of being rolled out. So the goods are currently still being moved by labor, but those are the next steps. So what's the map of this look like? Well, it starts with a cloud-based ERP. So our now ERP system is based in the cloud, and this communicates to the plant through an ESB, an enterprise service bus. And then at the plant, we have a server here at the plant as well The reason we have the server there is for high availability. So if the communication stops, sometimes these plants are in other countries, sometimes they're in the same building, sometimes they're down the road, but they might be across oceans. So if the communications fail, the plant can continue to run, continue to print labels, record tags, and so on, so that when the communications come up, it sends all the information back to the ERP. We're right back where we should have been. So the information being sent down can be the queue of the production. It can be operating instructions to PLC devices and to the robots. Then in the factory, the smart factory can track the production order progresses, if the machine stops, why does it stop, and also any machine performance indicators. And as well, the robotics are doing inventory transactions. So they're communicating when things go in and out of inventory. If it goes out of inventory as a raw material, what production order did it go to? As the goods are packed from a production order and moved back into inventory, we're also recording that. So this is what it looks like from a systems landscape. Here's a second example of automation. And this one, by the way, is over 12 years old. But what we're doing with the information now is a little bit different. So this is a yarn plant. And here we can see the automated DOF of the yarn package. So when it's produced, rather than a human taking the package off, the machine's taking the package off. There's a conveyor system running on the ceiling, or at least above the machines, and a robotic arm lifts the package up into the conveyor. The conveyor transports the product out of the manufacturing floor. As well, similar to what we've seen in the last couple presentations, we have a monitor here based on the communications of those actions, showing the operator their performance by machine or by spindle, by spinning frame, as well as by operator. So they can see how their efficiency is, color-coded based on whether they're meeting their targets or not, of course. Ultimately, the product's delivered to an automated packing line, the correct automated packing line, because of course there's more than one, because they're making more than one yarn count at the time. From here, based on the packing instructions, the automated packing line is either going to bag the yarn and put it in a box, or it could be putting it directly onto a pallet. So that's another example of the automation and how it communicates then back to the ERP. So the enabling technologies we have here are the cloud-based ERP. We're also utilizing flexible master data in these systems, detailed production orders, and integration. So let me speak about those a little bit. So the cloud-based ERP. So if you're able to move your ERP into the cloud, you have the opportunity to eliminate some of the IT hardware that you have in place today. So you're able to remove servers, you're able to remove cooling devices, you're able to remove backup power supplies, and all of this is going to be a big cost savings, as well as the energy that you used to have to consume to run all of those. You also make savings there. Plus, with cloud computing, it's a scalable solution so that when your heavy processing jobs are running, like your month-end financial closers or cycle counting, you can give more power to the cloud server. If your server's on premise, you almost have to over provision. You have to buy a strong enough server for the max requirements. And then the rest of the month, you're just paying for that functionality that you don't really utilize. So there's some real opportunity to reduce cost by moving your ERP into the cloud. More obvious solutions, remote work, anytime, anywhere access into your server. Security is an interesting one, right? When they first came out with the cloud, people are like, I'm not putting my data in the cloud, it's not safe. And now with all these malware attacks inside people's networks, they're like, I want Amazon to protect my data. I don't want my guys to protect my data. So there's certainly more security these days with cloud providers than perhaps inside your own IT structure. So there's some security benefits that can be realized by moving your data to the cloud. And power consumption. Certainly these cloud farms are designed with the latest in power generation, power utilization. It's more efficient generally than how you have your own IT department structured. Another enabling technology is a flexible ERP system. You want to make sure that you have dynamic product definition. You can easily assign new colors to a certain style or tweak the characteristics of your product without having to update hundreds of product master tables. Bills of material, you want to be dynamic. If I move this production order from this country to that country, I don't want to have to change all the bill of material. I want a dynamic bill of material that automatically changes things like my made in labels, or perhaps the width of the selvage based on this loom type versus that loom type, and how much yarn do we consume. As well as dynamic routings. As you're now going to schedule your production order steps, if you have to use an alternate machine, I want to make sure the system updates that and that I don't have to remember to go update that. So when I do actual costing, it's getting the costing of the machine I scheduled it on and not the costing of my standard machine. Detailed production orders, we want to make sure they're defined and scheduled production orders. Also, these can include things like the reclaim of material. If we're recovering cotton fibers that we can reuse, we want to make sure that's part of the production order. And also the expected energy and water consumption of that production order. For the integration to the MES Smart Factory, like we spoke about, sending the queue, sending the operating instructions, getting that information back into your system. So those are the technologies. These are the business benefits from those technologies. First, a digital view of your production status. It's important not to know just where is the product and how much is there, what step am I at. What step should you be at? Are you where you should be to make this delivery? If I'm in the third step of a 15-step dyeing and finishing routing, should I be at the fourth step? Should I be at the fifth step? I might not be late for my delivery date, but I might be late getting out of batching or getting out of washing. So it's important to know not just where you are, but where you should be. The actual costing of production, the cost of the production order versus our expected cost. We need to track what we plan this cost to be for this production order, and then based on the materials we issued, the start and stop times of every step, and the quantity we produced, how do those compare? What's the variance? Automated data collection. Biggest benefits of course, is lower cost. We're reducing our labor cost. Certain countries, that's bigger than others. In mine, it's pretty significant. But an even better benefit for everyone is the improved accuracy and the timeliness of the data collection. I don't want to have to wait till the end of the shift to find out how we're doing. I want to know how we're doing right now. By automated and timely data collection, we also can give real-time feedback to our people in our production area, as well as the managers who manage them. I spoke about the yarn conveyor system actually being old. Here's how we're actually using some of that data now that we weren't able to at the beginning. With the actual production and the error monitoring, we're reporting against the production order the quantity we produce, or even the time the machine's running, can cause our preventive maintenance orders to be triggered. So we can set up, I change a belt after X number of hours, or I have to clean out the filter after X number of pounds or kilos of fiber go through. So by automating that data collection, it can automatically trigger our preventive maintenance jobs into the maintenance team's queue. So it appears on their tablet for them to take care of without anyone having to tell them, oh, yes, it's the beginning of the quarter. We have to go clean that filter. The system's telling them automatically. Also, machine performance warnings. Some of the things you heard before, the temperature is getting too high or the vibrations are getting too strong. These can send not a planned maintenance, but an unplanned maintenance order into the maintenance system. So here we want to prevent a breakdown. It's a predictive type of thing. So if any of those triggers from your machine monitoring are worrisome based on your history, we can send we refer to as a breakdown maintenance, but we're really trying to prevent a maintenance order from coming in. And then the AI opportunities with the system. Here's a few we're working on. Taking this data, this real data collection, and updating our standard efficiencies, trying to make them more accurate based on the history of data we've collected. That's runtime, run speed, efficiency, shrink percentage, stretch percentage, waste percentage, all these different types of things that we're collecting and we use in our production routings to calculate cost, to calculate capacity consumption, and so on. Also, by doing quality assurance testing and referring back to the source or the provenance of the raw material, we can update preferred raw material source or working loss based on the quality performance. Another example is scheduling, that we're going to use this history of what products ran well where and update our scheduling preferences for the future manufacturing orders. So, okay, thank you for your time. And again, with Datatex, we're in Hall 9, B318, if you'd like to learn anything more about this. And Jonas,
yeah,
how are
thank you very much, Shannon.
Thanks.
Now we open up for questions from the audience. And if you want to ask some things about robots, Shannon will be happy.
Sure. We know how to get data from them and send instructions. If you want to know how they work, don't ask me.
No, no questions? All right. So I have a few questions. So one thing that we speak a lot about is collaboration between the partners in the value chain.
Sure.
And how does your technology enable that?
Yeah, thank you for the question. Good question. Yeah. So we're an ERP and we're in many areas of textiles, including some of our customers are business partners with each other. So we have a lot of digital data exchange, whether it is a purchase order from an upstream partner can electronically become a sales order for the other one without having to be rekeyed in. A shipment from the supplier becomes an advanced ship notice for their customer, so they know electronically what's coming. So when the goods arrive, they don't have to scan it. They have the inventory records. They just move it into a received state. So we have a lot of both entities, planning entities like purchase orders and sales orders, as well as inventory transactions going between the two.
Yeah. And that brings me to the other note about how does this enable, for example, the EU product passport with traceability and transparency?
Yeah, traceability, it's become the sustainability, rightfully so, a very important matter these days. And the key to it is traceability. Fortunately, for us in textiles, we've always done traceability, and it's an important for all of us. And I always think back to dyeing. This jacket I'm wearing, for example, the wool fiber was dyed together at one time, these blue stripes made into yarn, but then some went into warping and some waited for weaving. So when it comes time to weave, they have to make sure they're pulling the correct yarns that were dyed together back when they were fiber. So we've always had to have that traceability just for good quality apparel. We want to make sure color matches. So now we're able to provide that same traceability that we've always done to make sure our products are good quality for sustainability purposes. And I think the textile and apparel industry are better prepared for these sustainability requirements than most industries. I think we've all been doing it for a long time, and now it's just going to serve a different purpose. It's always served quality. Now it can serve sustainability.
Thank you very much, Shannon.
Yeah, you're welcome.
Yeah, and
appreciate it.
I enjoyed having you here.
Thanks.
And good luck at the rest of the show.
Thanks very much.
Yeah.
Yeah, appreciate it. Nice to meet you.
Nice to meet you too.